Yes.
Okay. Thank you to our speakers. I'd like to invite our panelists to join us. Sandra DiMatteo from Bentley Systems, Oz Rodriguez from Lloyd's Register, and Jared Hartness from GE Digital. And as they are making their way to the stage, I'd like to congratulate GE Digital and Bentley Systems for being the leaders in our recent iteration of the Asset Reliability Software and Services Study. So we have good representation here for them. Welcome, and thank you for joining us and for bringing us such great speakers. Any questions from the audience first? I'll ask that first. Oh, shy group. Okay, never fails. I have one here. ARC research and other research indicates, and it was brought up, I think, by our speakers as well, time-based maintenance is still the most widely practiced maintenance strategy out there. End users seem comfortable with sticking with OEM recommendations. Why does this practice persist when tools to detect and diagnose asset issues as well as prescribe corrective actions are readily available? Let me start with you, Scott. You have an opinion on that?
Well, again, it goes back to, I think, first to the organizational change discussion, that people are comfortable with what they've been doing. Mm-hmm. So I think the first issue is the organizational change. I think the second issue is recognizing that technology is cheaper now. I mean, I think people may have looked at something like this X years ago and it didn't work or it cost too much. I think that the technology to allow you to do a condition-based or a more predictive approach, the technology is available, it's cheap enough to use, and you can do it now. So I think the biggest issue is recognizing that you can be different, you can change, and then charting a path to make the change.
Okay. Daniel?
I would agree with Scott. At Suncor, a lot of what we get is, but we've always done it that way, so it's much easier to do what they've always done, which is time-based. We are looking a lot at our assets and where we can actually deploy instrumentation where it can be wireless, and we can do it to, like you said, Scott, much cheaper and get the data we need and start doing that condition-based monitoring. And so that's the direction we definitely want to move, but it is, you have to validate the economics and put the case together. And I think it's also part of where we're going with the equipment strategy development too, is looking at the right ways to detect your failures and making sure you have the systems in place to do that, and then the competent people to be able to monitor and respond accordingly.
Thank you. Steve?
So I'll answer with a little anecdotal story. We first attempted a risk-based type approach with RCM, so reliability-centered maintenance. The assets we looked at were fairly expensive assets, and it took us probably about 8 days to do an RCM analysis on this one particular asset set. We have 200,000 assets. There's no way we could carry that forward across our whole infrastructure, our whole system. So the risk-based approach we tackled here was more of a statistical-based approach. And that was a big learning for us. We had to contract in that skill set. We didn't have that skill set. So our consulting firm really brought us up to speed on that. Now my observation is 5 years on, as I look around, we've hired more engineers, and we have at least 4 engineers on staff that are all highly attuned to statistical analysis, to data analysis, and eagerly digging into this data. So we're going to be pursuing a whole new frontiers there because the skill set is now available to us that just wasn't there 5-10 years ago.
Sandra?
I agree. I think we hate change, but I think the old systems really encourage that type of behavior, right? So if you, in our old, only using an EAM, a CMMS system to manage asset health and not just maintenance, I mean, it was almost encouraging that with just managing, say, the work order backlog. That way. Now you have the tools available. There are reliability systems that we've talked about today that drive proactive behavior. So they were designed to manage a proactive approach to reliability. So it actually helps to change that culture and move it to proactive maintenance, as we've seen in these case studies.
Culture, there it is again, culture. Jared?
I would say, and this is kind of pointing back to what Scott said in his early career, a lot of times when we engage with customers, what we start to uncover is they're ultimately incentivizing that firefighting reactive culture of, can we take what an OEM said is a 10-hour job and get it down to 6 or get it down to 5, and ultimately are rewarding that within the organization. So I think the kind of step change for that is, how do you start to reward and incentivize integrating these proactive, predictive type approaches, and making it part of the culture to make the employees' jobs easier, less headaches. So.
Oz?
I agree with everything that we've said in the table, but I think
Excuse me, could you share the microphone, please?
better.
Yes.
So I agree with everything that we've said in the table. So to add something that we found with some of our customers, with a lot of them, is just the data and the quality of the data. If you look at time base, you start from a known place and you do things on a known frequency. If you want to go to a different engineering methodology, if you want to do RCM, if you want to do RBI, if you want to go to CVM, now you need more data points, and you need to verify that the quality of those data points are good, so that then what the information you're getting, the optimization you're getting, is the right approach. So having that data available, and that data in the quality that you're expecting it to be, it's been the most difficult barrier for us. We did our own survey, and we found that around 35% of people in the market that are still using time-based. And if you see where technology is right now, it's kind of astonishing that it's such. We didn't expect it to be that big, to be honest, but that's where we are right now.
Yeah, unfortunately, I believe that it's true, that we have the data to support it and the anecdotal information to support it. So we need to move the needle, and we're not really moving the needle. I don't quite understand what the hesitation is. But I think we are making progress. Anybody out in the audience have a question? We have one.
Thanks. I heard a lot about how difficult it is to work with plants that you've acquired and things like that. Scott talked about that. Stephen talked about, I'm running this whole program in Excel and it's generated great value. So how are you guys thinking about scaling and sustaining once you've built these great systems that you're working on?
Okay. Why don't we mix it up a little bit? Let's start with Daniel first.
Sure, that's definitely a challenge we have. We have lots of facilities. It's been talked about a couple times today where you want to kind of do that proof of concept, but you need to at least take that, engage these site people and make sure they have a voice in it as well, because you put something together and you deliver it to site. My team might think it's great and it gets to site and it turns out it's not what they're looking for. So it's really engaging the people and trying that concept at one site, working out the bugs, and then taking it to the next site. And it's kind of a continuous learning process. FAME, which is one of the programs I talked about, we've executed and implemented that at numerous sites across Suncor. Every time we do it, we're learning something new. So you're taking those lessons, you're implementing that into the next execution and making sure that when you do it the next time, you take those lessons learned. Every time we've gone to a new site, we've learned something new. So it's that continuous improvement that helps you get better and better as you go along.
Mm-hmm. Scott?
Well, again, Georgia Pacific grew by acquisition, so we have 150 sites. Sometimes it seems like with 150 solutions. One of the things that we've done is that we're not just going to rip out all the old stuff, but as we go to new solutions, we're looking at standard platforms. We're not really interested in a solution that only works in one location for one solution. So, example, we have multiple plywood plants. If we pick a site to test it, and the goal is, if it's interesting to us, we're going to put it across the whole fleet of plywood plants. And so we're trying to and goes back to sustainability. We cannot remote support, remote optimize, remote monitor unless, we're on more of a standard platform.
Right.
So again, as we go to solutions, we try to do a solution that impacts multiple sites. In a perfect world, everybody, but at a minimum, the fleet, the plywood fleet, the big paper mills, we try to have a common platform, because again, it goes back eventually to sustaining that. In the days of having 150 subject matter experts at 150 different locations or over, we've got to be able to do regional type supports or remote support, but we can't buy 150 solutions anymore. And so we have to, and I think what we've done is we've taken that vision, and the first few years of this path was communicating the vision that change had to take place, and getting that buy-in down through the organization. And as we've done a couple of these type solutions, and the speed at which we emphasize making these solutions has led to future success.
Okay. If I may just follow on view for that, are you finding if you standardize on the platform level, that the underpinnings of the platform level in the different plants that you've acquired, the interoperability with the platform allows them to remain the same as long as you're getting consistent data at a higher level?
Well, the biggest issue is, we've got mills, large paper mills, for example, that, and this is not obviously true, but I mean, it had like a Ford product, a Chevy product, a Ram, a Fiat, a Porsche in different parts of that same mill. You send Scott Carter to deal with it, and Scott Carter will come back and say, hey, I can help you with this Ford, but I don't know anything about Porsche. So over time, we've got to be able to get to a solution that is sustainable by more people. We can't have, again, all these specialties.
Yeah.
And again, it goes back to that talent discussion. Maybe in the past, you were able to have enough talent to manage all those different diverse products. But as they leave and take that knowledge with them, it's very difficult to replace.
Yeah.
So again, we're not dictating thou shalt do this across 150 sites, but again, if we're going to do something, that ought to be interesting to a segment of the sites, so that we can then do a better job of supporting them.
Yeah. Stephen?
So you're right, Excel is not a long-term solution. It was good for developing kind of all the math and the engineering, and we've been struggling with it for now on kind of an annual batch update basis. But our growth doesn't come so much from acquisition and mergers. It's more from, or change anyway, is from changes in technology. So you may have heard about, smart cities and advanced metering infrastructure and remote sensing. We now have available to us probably about 500,000 sensing points across the city of Edmonton from all our smart meters and improved control sensing. So we're looking at cloud-based solutions to help us curate all that data and analyze it at rates that we just can't handle right now on a conventional desktop. So that's our push for the future and change in technology.
Sandra?
I'd like to just touch on the engineering data, since the question was about growing through acquisition. And I think that's a really scary thing that happens all the time. Acquiring plants and you don't have any data, you don't know what you've got. Do you know what and where all your assets are? Do you know the specifications? When you have a problem, do you know when you go to that document or that model or that diagram or the PNID that it's going to be accurate, and you need it to be accurate? So, I mean, that's really where the digital twin comes in. We talked a little bit this morning in the keynotes about IT, OT, and ET, and I think ET, that connection, is sort of the next step for that integrity and that trustworthiness of our data going forward.
Yeah, I agree. Jared?
So I would say I completely agree that we see a lot of times mergers and acquisitions as an inflection point for buying technologies. But I would say the first thing before you even start to touch and look at vendors when it comes to mergers and acquisitions is, and rationalizing that across sites, is first rationalizing the work processes across those sites. Because one, if you've got 10 different work processes at 10 different sites, you're not going to be able to dovetail technology into that work process that ultimately supports it and gets the outcome. So starts with the work process. How do we enable that and then drive technology into that to integrate and automate it and ultimately help support decisions around that.
Oz?
Yeah, I have to agree that when we found companies with a large landscape of different applications trying to do the same thing, they're usually not doing the same thing, although they're labeled to be APM systems or CMMS or EAM. They're done or they're used by different maybe users on different processes, different outcomes, different requirements. So standardizing, although it's a really good idea, and we've kind of helped some of our customers go through that journey, it needs to be taken into account from the user perspective first, from what is that system is truly doing, and what is the output that is expected from that system within the context of the process that you want to be doing at that point. So it's a really complicated question, but I think the best way to answer is always look at it from the user perspective and not so much from the technology. Although it sounds like a technology problem, it's more of a user and process problem.
Yeah, a lot of times it is. A lot of times it is. We have a question.
Yeah, I'd like to go back to your first question about time-based maintenance, and I didn't hear it explicitly. I guess the question I have is really how much is trust, right? The guy's been doing it for 20 years and it's always worked. How have we explained to him that this data is better than what you've done? And I'd throw a simple anecdote out there. How many people change your car oil based on mileage versus what the thing tells you? And then go out and try and figure out, why should I trust that monitor that says I got 50% oil life left? I can't find what the metrics are. How did they come up with that? Is it just based on engine hours or something else? And so like I say, it's trust. How do I know I can trust that data versus what I've done for the last 30 years?
Good point. I trust the gauge. I believe what it tells me, because then I don't have to do it as often. But anyway, let's start with Stephen this time.
I'm on the spot. Well, if you're ever in a helicopter and the oil light comes on, land. For us, our tradesmen are perfectly comfortable waiting till the asset fails in a big fireball before doing anything with them. Most of our assets, there's not a lot we can do in terms of maintenance. In our substations and in our more high-tech network environment, we have a lot of maintenance we can do, and we're quite rigorous about that. Like I say, for the most part, I think our tradesmen don't think about it. But for those that are working in the higher tech equipment, they would be more than happy not to be out in the minus 20-degree weather doing some maintenance that we could defer till the spring.
No. Sandra?
I mean, there's proven data out there that shows that with just a time-based approach, you're either going to be doing too much too soon or too little too late. So it's that classic, reliability-centered thinking, and there's, again, tons of data out there that gets you to that base work, which is the right work at the right time. I think someone said that today. And then one asset at a time, moving those assets. You don't have to start, all at once.
Yeah, so if I could, my point about trust wasn't that the data is not valid, but how have you communicated that to the maintenance guy so that he can trust the data?
What we've done, And sorry, just to comment on that, because what we've done is you have to educate everyone in the organization on that reliability-centered thinking. Just that should be standard training, that they understand reliability, and they'll get it.
If I could interject here, you might want to tell them, well, we're going to do it this way, because if we're just doing it when the OEM tells us to, and there's really nothing wrong, we could actually be introducing an issue that didn't exist before.
That's true.
Think about that. Jared?
Yeah, so I would say, and this gets back to the change management and kind of engagement thing, is we've literally, and a good example is one that came from one of our customers that was implementing a rounds walk-around program, right? So this was on actually big portion of the non-connected equipment. But what they did was the champion of the project actually went and took operators and the maintenance team out on pump walkarounds and started looking for stuff and showed them, and they would be amazed at what they find, right, that they didn't know was out there. And so it's that engagement of them starting to see it actually come to life. And did it make the job that I ultimately had to do from a technician standpoint easier? I didn't have to do a full rebuild. We were able to just replace a component or something like that. So I think it's that classic show and tell example.
Interesting. Daniel?
So at Suncor, I think it's less about trusting the data and trying to convince them that's the right way to go. We've seen two different responses. One is from folks of, you're actually looking to do this less often, which means there's less work to do. So there's a risk to, you can now start cutting headcount. But at Suncor, we have no shortage of work for them to do. The other response we get is kind of what Stephen was saying is, they're time-based. Well, when it's minus 45 out there and they have to go out and overhaul a pump just because it's time-based, they're not too happy about doing that and being out there in that kind of weather. So when you can show them the advantages of the condition-based, that actually you can do it on a more planned basis and maybe get out of that minus 45-degree weather, they see that as a big positive. So haven't really seen the concern with, I don't trust the data.
Interesting. Oz?
It's a joke, but it's not a joke. Pair that guy with a millennial, and you will see, and you will see the difference, because we're used to doing our thing. The people, the workforce that understand and know the asset left and right, and they're able to analyze that equipment. But then comes the new force, and they're always looking for data. They're always looking for that evidence. They're always looking to optimize things, and honestly, to do the little that they can do and provide more value. And we've found, and we've done actual I've been in a couple of workshops where we have customers that have a mixture of these two type of the new workforce coming on, learning from the people that have been there in the plant, that understand the equipment, that understand this boiler has failed this many times, this rotating equipment we have to take a look at next year. And the way that the dynamics and how they self-challenge themselves, and they ask him but there's no data points that tell me that that's gonna fail next year. I'm maybe overdoing this. The dynamics are really interesting, and it was really enlightening to see how those two different groups, one that's really data hungry, another group that relies a lot on intuition and the things that we don't see sometimes, and doing a schedule point maintenance or inspection. It just came to life, and it was very interesting to see the dynamics between those two groups. So I think that there was quite a few lessons learned from that exercise.
Thank you. Scott?
Well, I guess I was sitting here thinking about this, and I'm not sure if the harder sell is to the maintenance guy or to the operations team. So, I mean, it's a little bit of both. But in our case, as we've gone down this path, we've actually had some clear wins. So I guess the best solution for us was to leverage seeing that win, that we don't have to do time-based, because we're having new tools that digitally show you what is at most risk. And once you start having some wins with that's made a big difference for us. So I think the proof was actually doing it.
We have one. Oh, I'll get to you next. I like it.
Thank you. This question is probably more focused to Daniel, but anyone's willing to respond. But as you talked about your asset performance management and rolling out some of the more predictive analytic tools that are across your energy sites, is Suncor as a company doing any kind of enterprise type fleet-wide analytics? So, or is that left to the individual sites to use the APM program, as opposed to looking more at like a equipment type or fixed asset class that you're saying internal benchmarking versus external benchmarking, things like that?
So first, it's focused on what we consider our most critical assets based on asset criticality. So, your single point of failure, like an FCC main air blower and things like that, what is going to cause you the most pain from a production loss standpoint and economic impact? And then it's working with those sites as we identify the equipment to help them understand the value they're going to get by having it deployed. To your point, when we do have similar assets across the enterprise, we definitely do look to deploy this in a similar fashion across the same assets because you're going to end up getting the same value. It's actually been from the APM RAW program that we probably received the most pushback from people. Again, the concept of you're going to start doing this detailed diagnostics so we can detect the really small problems, which is going to minimize failures, minimize the amount of work. But once we start going forward and show them the value, and to Scott's point, show them the wins, and all we're doing is actually redirecting their focus on something else, and it turns into they realize the value of not having that reactive work and having that more planned work. But to answer your question, we definitely are looking enterprise-wide on how we can deploy these strategies on similar equipment to get the most value across all the assets.
Scott, something to share?
Um,
No? Stephen? No? Anybody else?
I think just the beauty of looking at the whole fleet is being able to templatize then and then get quicker wins across, the enterprise.
Yeah, consistency. I think it brings consistency. And I think that's the basis of improvement in comparison, quite frankly. Next.
I wanted to kind of get back to something you had right at the beginning, which is asset health is more than just maintenance. And Scott, you mentioned it, 50% of asset health issues are related with process or operating it in a specific way. So in your journey on APM and asset health, how do you get that kind of people from the process, production, operations involved, and how you go about doing that?
Well, at Georgia Pacific, the operational team actually owns maintenance. And so that's the perspective they have, is that ultimately operations owns reliability, they own maintenance. And so, which I struggle with because I grew up in a world where I own the equipment, just let the operators run it. But that's very not the way we do business now. And so that wasn't a hard sell in that ultimately we've got to make product out the door where, paper mill is kind of like the metric of success is tons of paper out the door. And so the way you make tons is your equipment is available. And if it's not available due to an unplanned event, then you're not running, you're not making tons. And it really doesn't matter if the unplanned event was caused by a process issue or quote unquote maintenance or reliability. So that we really, those are all interlinked for us. There's really no, they're so interconnected that they're looked at in the same way. But again, as we've gone down this digital transformation path, as you hear, this week, some of the new tools that we have is that you literally can see that your way you run the process is causing these unplanned events. Some cases because it's wrecking equipment. And so it's looked at holistically by the operations team, and reliability and maintenance are interconnected with the operations team.
Interesting.
So my boss wants to say something. I hope I was right. Something like that.
Excuse me, can you get him a microphone?
So the question is, we got nearly 100,000 sensors across, of one kind, right? Look at him. He's shying away from me here. Right, so we got nearly 100,000 sensors across just of one kind, across our footprint. And the question is more better, right? So
Not necessarily.
what do you guys think, right?
You asking me or them?
I'm asking you and then all of them.
So, I mean, I think that there's a baseline number of of sensors that you have to have. So, you know, if you've got your car, you got to have a gas gauge, you got to have certain gauges. And what's interesting now is that if you buy a newer car, there's things in there to keep you from running into walls or running into other cars and things of that nature. So I think there's a base number of sensors you need to establish a base of reliability. And at some point, if you do more, it gives you more visibility so you can do better. I'm sure you reach a point where there's too many or there's diminishing value at some point. But I mean, the way we were running our equipment with 0 sensors or just the basic gas gauge and temperature gauge was all we had on some of our equipment, so to speak, wasn't enough.
And we haven't found that point yet, was my point.
We haven't found our point yet where, that we've got too many.
Interesting. Stephen, yes.
Okay, so I'd like to add that two things. So one depends on where's your critical assets and are you monitoring them? So for power utilities, cable is our single largest contributor to defective equipment outages. Yet outside the substation gate, we don't have much monitoring on really what's going on with that cable. It's all calculated and estimated. In the good old days, it was estimated by a control room operator in his head. Now we have some better control systems. We've got some better calculator estimating that. So as this automatic metering infrastructure comes online, we have better opportunities to calculate and determine the actual loading on those critical assets. The other driver is what's your competition doing? So we've got that metering infrastructure in place largely for billing, completely justified on billing. We could just ignore that and continue on with our rather crude estimation. But if our competitor down the road, another city, another municipality, leverages that data and exposes that to the regulator, then all of a sudden we'd be considered to be imprudent, right? Not following good practice, and that would be lead to disallowances and penalties for us. So it depends on your critical assets and what do you need to do to remain competitive and economical.
So just to add a different twist on that, so how many of y'all, have control loops and you monitor the quality of your control loops and are they in the right state of on or off or automatic? Any of y'all do that? So anyway, in our world, we have a lot of control loops in our systems. And initially it was like, well, we're just going to do the most important ones. And what was interesting, we started looking at all of them and we found that some of the so-called non-critical loops are the ones that are causing us the most problem. And some of that is kind of second and third order effects of most of our places are continuous processes. And so I guess that's another learning is as we've gone down, we're using some tools that evaluate risk and rank the risk to our process. You think they'd be, our big ticket items, a paper machine or something. But often some of our most critical assets or the things that cause us the most problems are not our quote unquote critical assets, but ultimately they're the ones that cost us the downtime.
I guess, yeah, I'd
But,
make a
excuse
comment.
me, but by definition, do those become critical or should they be critical?
Well, then you reach a point where everything you got is critical. So, it's an interesting, your car. So, if you got a flat tire, maybe that's not, you think, well, the engine's critical and the transmission's critical and all that, but if you got a flat tire, suddenly the flat tire is critical. So it becomes an interesting discussion of what is critical.
It
We've
can
had-
change.
We've had those same discussions as Suncor. So to what you said, Stephen, where you deploy your most instrumentation and your most focus is on the most critical assets. In fact, on our decriticality assets, we do not develop equipment strategies that are basically run to failure. But then Scott, to your point, sometimes your assets that are not your critical assets, because of repeat failures and other problems, they end up being some of your pain points. And so those are what we call our bad actors, right? It doesn't mean you're going to go out and spend a lot of money on instrumentation, but they are causing you pain because of multiple failures or in multiple locations. So you need to figure out what the root cause to that is and actually address the root cause to eliminate that as a bad actor, but it does not necessarily turn it into a critical piece of equipment. But it is something you have to address.
So in our industry 10 or 15 years ago, we put sensors on some of our most expensive and, big pieces of equipment because the sensors were expensive. I guess the point being now that, again, technology's gotten a lot cheaper.
Right.
You can put more sensors out on more things because they're dramatically cheaper and easier to network than they were in the past.
Okay, we're kind of getting up against it, but we'll take your last question.
You basically were saying, to Scott's point, he has a different type of scenario based on his equipment that versus, there's so much variability in what he's doing there. So I think having sensors and the right sensors is define your business problem first, or where your biggest issue is, and then use that technology. And I think the other gentleman mentioned earlier is look at your workflows and where your biggest problem is, start solving those. And if sensors is the right technology to put on it, that's where you should lead.
Yeah, I don't disagree at all. Anybody, panelists, do you have any thoughts on his comment before we close?
Yeah, just,
This is your last opportunity, so get it out.
no, just quickly, you also have to take into account that the more sensors you have, the more data points you have, that also is an added cost, because then you want to make sense of that information. So then you have to analyze the information. You have to create the models to take that information and really use it. So as you expand your footprint, then it's not only the hardware and the infrastructure to get that information in, but also the analysis part of the data. And at some point, you're not going to get as much insight as when you started. So the curve of the insight is going to kind of flatten out. So I will say that.
Jared?
Yeah, I would say this is where you guys nailed it talking about criticality risk, right? And that's going to define where the investment in that type of technology goes. But as it gets cheaper, and that threshold of substantiating that investment on, say, a medium to low critical piece of equipment, and criticality not just being how expensive the asset is, but all the various impacts of how you look at risk, is how do you start to then use technology to start to automate some of the decision support around that, using risk as the threshold, right? Because as the data population gets bigger and we're consuming more, you have a threshold of what do I look at, right? So that's where technology can start to really come in, help with that decision support, and what do I need to be looking at that's ultimately going to have the most impact on the business if something were to go wrong. So I think it's an interesting place where we've seen some use cases starting to tie all that together.
Sandra?
I guess we haven't talked about machine learning, but that's, as we get more and more data, then that's one area where machine learning can help to, are you actually using that data to do something? Is it necessary? If not, then, you don't need to be collecting some of that data.
Yeah, if you're not going to do anything with it, there really is no point in collecting it. It's like that thing that sits on the shelf. Well, why? It's a dust collector. Stephen?
Yeah, data analytics as well is our next frontier. It's our big push probably this year. I'll go back and see if my project got approved. Just where we are, where most utilities are at, we're hungry for more data. We want to retain all this data that we're collecting. We want to put it in a warehouse and we want to analyze it. And that's where we see the value is in the analysis of that data. We've got some relays that can create 1,000 different indicators, but we need to do some analysis on that data to figure out which indicators are material in determining the life of the relay, the life of the distribution system downstream from that.
Daniel?
So data and visualization was one of the streams of our ERAM program. We've done a really good job at Suncor in the past of taking a bunch of data and turning that data into a bunch of pretty graphs and charts and basically showing people that, here's what your numbers mean in graphical terms. And now it's moving that next step of actually taking that data, analyzing the data, and turning it into a dashboard that actually tells you something, not just what the number is in a graph, but it tells you the health of your equipment, and it actually gives you a direction of what do I need to do to actually do something different to improve the health of that asset. So that's our big direction that we're heading in. The other thing we're finding is, guess what? You may have a lot of data, but it comes down to data quality as well. And sometimes you find that the quality of the data is crappy, and that's actually a really good thing, because then you can go back to the sites and educate them on what is the right way to enter the data so you actually have good data going forward, because you don't want to be making bad decisions off of bad data.
Yeah, I'm sorry we don't have time to go into that, but I know Suncor's got a great story to go along with that. Share it with you anytime. Scott?
Well, I'll just say we're at a tipping point where You don't need to send operators and maintenance guys wandering around looking for problems. There's enough sensors and data that will feed into a system that will tell you, when a leader walks into the plant first thing in the morning, here's the top 10 things I need to worry about, and actually dispatch the workers to where they need to go to do maintenance. So, it's available. The technology's there, the various systems are there. Again, it's just the organizational change of how do you convince someone that, yeah, they need to do that versus, changing the oil every 3,000 miles. So it's amazing that the technology that's available is at a tipping point on cost and capability to dramatically change the way we approach reliability.
So it seems to me that my premise in the beginning, that we're no longer drowning in data, but we have kind of figured it out and we want more. That's what I heard here today. I hope everyone else heard the same story. So I'd like to thank all of our panelists and speakers today. Thank you for joining us. Excellent job. Great stories. How about a big round of applause? Thank you for your attention and participation. Cocktails. Enjoy.